Hi everyone. So in this video, I'm going to go over activity 10.2 where you're computing correlations. So I already have the data entered here for spacing score, exam score, and rereading. Okay, so we're going to look at each of these separately as it does in the activity, each correlation separately. Okay, so what we're looking at is how the extent to which people space out their practice is associated with exam scores, and we're predicting, and we would expect based on research, that more spaced out studying leads to better exam scores. And then we're going to look at the extent to which people reread the book. Okay, but we're going to start with the spacing here. So to run a correlation, you click on the regression menu. So click on regression and then correlation matrix. And then we're going to start by looking at exam scores and their spacing scores. Right? So higher exam scores are better, and higher spacing scores mean that people have spaced out their work more. Okay. So we're doing a Pearson correlation here. So it's already selected Pearson correlation, but if it's not, make sure Pearson is selected. And then we're going to look at our correlation over on the right-hand side, okay, in the output. All right, while we're doing this, let's also get confidence intervals, 95% confidence intervals around the correlation. And then we can also look at the correlation matrix. Okay. So down below here, you can see the correlation scatter plot, right? Looking at exam scores and spacing scores, right? And you can see that there seems to be an upward trend in the data, right? And that overall, higher spacing scores are associated with higher exam scores. Okay. Now, if we look up at the table for the correlation matrix, we can see the correlation we're looking at is 0.31. Right? So the correlation is 0.31 versus spacing and exam scores. And then the p-value is 0.3759, right? So it's really likely that the correlation we're observing is just because of sampling error, right? With a correlation of 0.37, it's really likely it's due to sampling error. We also have our confidence intervals, 95% confidence intervals around the correlation, right? So the lower bound is negative 0.39 and the upper bound is 0.79, which is a really wide confidence interval. It's not surprising because we're working with a really, really small sample here. Okay. All right. So note here that we left the hypotheses as two-tailed. We did alternative hypotheses as correlated two-tailed, and the whole activity here is two-tailed. Okay. You're also going to look at rereading, and that is, was rereading associated with higher scores? And so all you do is move the rereading variable over to the variables box. You can take out the spacing score, and you can leave everything over here selected. Okay. So here we have a P of 0.08 and an R of 0.08 and a P of 0.82, right? So again, really likely that the difference or the correlation we're observing is just because of sampling error. I note here that I opted to look at just one correlation at a time. You could actually put all three variables in at once, right? And then you would get the correlations amongst all three variables simultaneously. Right? You would get an additional correlation here. You would also see the correlation between rereading and spacing score. Okay. All right, so that's really all you need to do activity 10.2 there. All right, so good luck.